All right, so today we're going to try to build a SolidWorks model of a slingshot. We begin by selecting the front plane. There is a center point on that. We'll create a circle, which will be a reference for us. It's not hard to do. Just point and drag, and we'll dimension that circle as 0.375 inches in radius. Next, we'll draw a line from the circle to start to make the handle of the slingshot, and we'll make that about 4 inches long. Next, we'll add one of the first arms of the slingshot after creating a center line. Here's the first arm. Going to make the arm 3 inches in length, and we'll have it span out at an angle of 120 degrees. So what you can see from this movie of making a slingshot, SolidWorks is a purely graphical program. There are a series of menus on how to lay out a two-dimensional structure and then to extrude it into 3 dimensions. And what's really nice about SolidWorks is that it allows you then to ship the final document off to a machine shop directly, so the parts can be made without any interpretation manually of the drawing. So we now have the one arm to the slingshot. We're going to add the other arm. We mirrored it. And then we're going to extrude. And we add depth to that surface. And now you can see the slingshot is taking shape. All right. After that, we're going to round off some of these edges. If we were actually making this in a machine shop, we would put chamfers or rounded edges on various parts of the slingshot. So we can select surfaces in SolidWorks and have SolidWorks itself round off the edges. All right, now I've rounded off most of the edges. I'll do a little bit at the top as well. And you can see the final shape of the slingshot here. So next thing we'll do is we'll think about the edges of this slingshot and how we're going to simulate the stresses and strains in the slingshot. So we begin by taking a part of the slingshot and assuming that it's rigid and fixed. And so that part for this slingshot will be the handle. We'll start by making a material for the slingshot, selecting a material. Why not make it out of plastic? We'll pick nylon, a particular kind of nylon, have certain properties, and then we'll assume that those properties hold for the whole structure. Now we're anchoring the handle, making it rigid. And we're going to apply a load, and the loads will apply at the tips of the slingshot's arms. So we'll put a load here, a load there. These loads will be 50 newtons each. Sorry, 10 newtons each. And now we'll simulate this slingshot with a numerical built-in simulation in SolidWorks. So you can see here these are stresses and color is coded in stresses. Looks like the maximum stress is about 2 times 10 to the 7th newtons per meter squared, whereas the yield stress is 6 times 10 to the 7th newtons per meter squared. So it's not going to break. And we get that just by using the generic properties of nylon that are built into the device. So now we'll change the load to 25 newtons. I'm sorry, to 20 newtons. Run the simulation again. And now you can see that the stress has risen to be 4 times 10 to the minus 7, and the deflection now is 1.6 times 10 to the 1 millimeters. That's 16 millimeters. That's quite a lot. It's a little more than a centimeter and a half. So let's change the property of the Slingshot. Instead of making it out of nylon, which is somewhat flexible, let's make it out of an aluminum alloy, 6061, which is a fairly common aluminum alloy. So we make it with the aluminum alloy. The yield strength is now for that 5 times 10 to the 7th newtons per meter squared, and the stress now is 4 times 10 to the 7th newtons per meter squared, so it survives that. With the 20 Newton load, we now have 0.24 millimeters. That's 240 microns. It's an acceptable deflection. We can look at the stresses as we load this Slingshot, and we see that everything seems to be in pretty good shape. So the idea is with the SolidWorks that we're able to model both deflection and stress in the Slingshot,